Welcome to This Explainer. Today, we are tackling what is, without a doubt, one of the most notoriously misunderstood areas in the entire Cambridge 0606 additional mathematics syllabus. We're talking about solving those multi-layered, heavily weighted problems involving the midpoint, calculating the length of a line, and finding the exact equation of a perpendicular bisector. Now, you might be wondering, how do we actually conquer these questions without losing our minds? Well, we're going to use a highly specific, proven strategy that I like to call the paleontologist. Think about it for a second. Just like a paleontologist carefully and systematically digs through millions of years of fossil layers to accurately reconstruct a massive dinosaur, you and I need to dig through the complex, often intimidating layers of a Cambridge math question to reconstruct a flawless, full-marks answer. We're not just guessing here. We're going to unearth exactly what those examiners are looking for, layer by layer, mark by mark.
Look at this quote directly from the Cambridge Principal Examiner Report. This literally flips how so many students view mathematics completely on its head. It says, even if your final answer is wrong, method marks can save you. Think about the anatomy of a perpendicular bisector question. It is never just one simple operation, right? It's a whole journey. First, you're finding your coordinates. Then you're calculating a gradient. Next, you have to remember to take the negative reciprocal of that gradient. After that, you're establishing your midpoint. And finally, you're plugging all of that into a formula to create a linear equation. It is a lot. And let's be real, if you're under exam pressure and you accidentally drop a negative sign in step 1, your final numerical answer is guaranteed to be completely wrong. But here is the secret. By clearly laying out your structural methodology, the examiner's method mark lifeline acts as your ultimate safety net. If you show your work, you can still score 80 to 90% of the marks for a question where the final answer is technically incorrect. That is a massive game changer.
Here is our masterclass agenda for today. We're going to cover the method mark lifeline, dive into the core theoretical foundations, break down the strict procedural sequence, look at some top examiner warnings, and finish up with evaluative thinking strategies.
All right, let's jump straight into Section 1, the method mark lifeline.
Okay, let's establish a foundational truth about multi-stage mathematical analysis. The absolute biggest challenge in these exams isn't the raw calculation itself. It's how you document your journey to the answer. Let's look at two classic student archetypes who consistently lose marks, even when they actually know the math. First, we have the overloader. Let's call him Alex. Alex looks at a perpendicular bisector question and completely panics, dumping every raw math fact and formula he knows onto the page without any logical structure or analysis. The examiner has no idea what Alex is trying to do. On the other end of the spectrum, we have the rusher. Let's call her Sam. Sam is brilliant at mental math, so she rushes the entire process. She tries to do everything in her head, completely misses crucial command words like show that, and jumps straight to an unverified final answer. Guess what? When the examiner pulls out their red pen, both Alex and Sam lose massive marks. Neither of these approaches works. You cannot just state random formulas, and you absolutely cannot just write down a final answer. You have to actively prove your method.
So what is the fix? It's the method mark strategy. By definition, this is a grading principle where marks are specifically awarded for the correct systematic process and clear working, even if the final numerical answer is incorrect. In the context of coordinate geometry, this means explicitly writing down your coordinate brackets. It means actually writing out change in y over change in x before you start blindly substituting numbers. It means labeling your midpoint calculation clearly so the examiner knows exactly what that random pair of numbers represents. Showing your step-by-step working isn't just about being neat, it is literally free insurance for your grade. When you document your process, you are holding the examiner's hand and forcing them to give you points for every single correct thought you had along the way.
Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Moving right along to Section 2, Core Theoretical Foundations.
If you read through the principal examiner's notes, and trust me, I've read them all, they make one thing explicitly clear. The candidates who achieve significantly higher marks are the ones who move away from isolated knowledge and actually demonstrate cross-topic connections. What does that mean? Well, finding a perpendicular bisector isn't just a fun little isolated geometry topic. That line you just painfully found the equation for, it might intersect with a quadratic curve in part B of the question, which suddenly, out of nowhere, turns this into a complex simultaneous equations problem. Or, you need to understand the deeper definition, that a perpendicular bisector is actually the locus of points equidistant from two fixed points. When you grasp that precise causal relationship, you elevate your cognitive domain from mere rote memorization to true high-level application and analysis. You stop seeing math as separate little boxes and start seeing the whole interconnected puzzle.
Okay, let's get practical with Section 3, the procedural sequence.
Top students don't just wing it.
They use a strict, standardized 5-step sequence like a blueprint to execute these multi-stage questions flawlessly. Here is exactly what you need to do. Step 1. Identify key elements. This means decoding the command words. Does it say calculate, show that, or find? Each requires a different level of detail. Step 2. Apply relevant principles. This is where you recognize, okay, I need a midpoint, and I need a perpendicular gradient, which is the negative reciprocal. Step 3. Execute with clear working. Lay out your algebra neatly, line by line, no scribbling in the margins. Step 4. Verify results. Take a few seconds to check if your midpoint actually balances when plugged back into your bisector equation. And finally, Step 5. Present in format. If the question asks for the equation in the form ax plus by plus c equals 0, and you leave it as y equals mx plus c, you just threw away a completely avoidable mark. Ensure your final presentation perfectly matches the examiner's request.
Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Now, how do we make sure we actually hit all 5 of those steps under the intense pressure of a ticking clock? We can overlay our sequence with a framework you might actually recognize from your humanities classes, the Peel framework. Yes, Peel works for math. P is for point. Identify the geometric element you are finding right now, like writing midpoint m equals on your paper. E is for evidence. Write down the correct algebraic formula you are about to use before putting the numbers in. The second E is for explanation. Execute your clear working, showing the line-by-line simplification of your fractions in algebra. And finally, L is for link. Verify your format and presentation, directly linking your final answer back to the exact format requested in the original prompt. Adapting this Peel structure makes it incredibly easy, almost effortless, for an examiner to follow your logical argument and award you maximum marks.
Let's shift gears into our interactive workshop phase with Section 4, Top Examiner Warnings.
I want you to imagine you're scanning a complex math answer looking for the flaw. There are 3 critical, consistent mistakes that trip up thousands of students every single year. Mistake number 1, confusing cause and effect. In coordinate geometry, students constantly assume 2 lines are perpendicular without actually proving it mathematically. Or worse, they rush and use the original gradient to build their equation instead of calculating the negative reciprocal. Mistake number 2, forgetting to check format and presentation. We touched on this, but it's huge. If a question specifically demands integer coefficients, meaning whole numbers, and you leave your answer packed with fractions, you instantly drop marks. It's a careless error. Mistake number 3, answers not specific to the given context. Let's say a question gives you a real-world context modeled on a coordinate grid, maybe dealing with lengths of physical objects. If you calculate a negative length and just leave it there without realizing a physical length must be positive, your final answer doesn't reflect the specific constraints of reality. The examiner will penalize you for not analyzing the context.
Finally, let's look at Section 5, Evaluative Thinking Strategies.
If you want to elevate a standard average answer into a top-tier, grade-boosting response, you have to make a cognitive leap. We have to move way beyond the descriptive level. Descriptive is just stating formulas, it's basic recall. The next step up is the analytical level, where students can execute the working smoothly and systematically. Most good students stop here, but the truly top-scoring candidates reach the evaluative level. This means you are actively questioning assumptions, comparing alternative mathematical approaches, and justifying your decisions with concrete evidence. For example, in a perpendicular bisector question, an evaluative student will quickly double-check their final equation by picking a random test point on their new line and mentally proving that it is indeed equidistant from the original segment's 2 endpoints. They evaluate their own work in real time, practically guaranteeing their own success before they even hand the paper in.
Let's pull this all together and summarize everything into the complete answering system. This is your ultimate cheat sheet. Rule 1. Command word decoding. You must absolutely always start by translating the examiner's language. Know exactly what show that means versus solve. Rule 2. Peel framework application. Structure your math just like a logical step-by-step argument, so the examiner never, ever has to guess where a random number came from. Rule 3. The time management matrix. This is crucial. Understand the fundamental rule that a 5-mark question deserves roughly 5 minutes of your time. If you find yourself stuck on a midpoint calculation for 10 minutes, you need to step back, reevaluate your method, and recognize that you've likely gone down the wrong path.
Students who implement these mathematics strategies see an average improvement of 12 grade boundaries. but only if they practice consistently with our weekly videos. It is entirely about understanding the hidden mechanics of the exam and systematically capturing every single method mark available through incredibly clear, logical communication. 2 whole grade boundaries. That is the difference between an average result and an absolutely exceptional one.
Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.
I am going to leave you with this one final, provocative thought to really ponder as you sit down to tackle your next grueling set of past papers. Ask yourself, are you just finding the answer, or are you actually proving the method? Shift your mindset from merely hunting for a final number to acting like a true paleontologist, systematically unearthing every single layer of your mathematical reasoning. Prove your method, capture your marks. Keep studying smart, and we'll see you next time.